Now we'll see how to find the center of a tree. To find the center of a tree, we should first know how to get the eccentricity and radius. Eccentricity is defined with respect to a particular vertex given by the maximum distance between 2 points. Eccentricity denoted by E of B, E of V. V belongs to a vertex set such that it is a value where we pick up the maximum distance between the 2 points. And the radius, after finding the eccentricity of every vertex, the radius is nothing but minimum of the eccentricity, minimum of E of V. So let us see in the following example how to get the eccentricity and radius, after which we'll know how to get the center of a tree. So this is our example. We find tree which has got 6 vertices, and we will see now how to get the eccentricity followed by radius. Eccentricity means it is with respect to every vertex. We have to simply see from the specific vertex, the considered vertex, to all the different other vertices. Find the distance. And whatever the maximum distance we get, that is going to be called as eccentricity. So to start with the first vertex, U1. Let us find the eccentricity of the first point, U1. That is E of U1. What I have to do? What do we have to do? It is all simply from the vertex U1. For U1 only we are going to find the eccentricity. So from U1, traveling to U2, then U3, then U4, then U5, then U6. For every pair, get the distance. How to find the distance? Simply we are going to measure the number of edges between that pair. Say, from U1 to U2, which distance between U1 and U2 is only 1 edge. So I simply write the distance between U1 and U2 is 1. The distance between U1 and U3, 1 plus 1, 2 edge. Then distance between U1 and U4, 1, 2, 2 edge. Then distance between U1 and U5, 1, 2, 3, 3 edge. Then distance between U1 and U6, 1, 2, 3, 3 edge. So all these are the different values, the distances between the vertex U1 and to all the different vertices. So out of these distance, what is the maximum value? That maximum value is called as eccentricity. So 1, 2, 2, 3, 3. The maximum value is 3. So E of U1 is 3. This is the eccentricity of the first vertex. Like this, we are going to find the eccentricity of the remaining vertices. So now we are going to find eccentricity of second point U2. That means what? From the vertex U2 to every other vertex, measure the distance. So to start with, from U2 to U1, how many edges we have? Only 1 edge. From U2 to U3, how many edge we have? Only 1 edge. From U2 to U4, how many edge we have? Only 1 edge. From U2 to U5, we have 2 edge. From U2 to U6, we have 2 edges. So we write down the distance between the pair of points from the particular vertex U2 to the remaining other vertices. From this distance, choose the maximum value. The maximum number is 2. So the eccentricity of the second vertex, simply the value 2. Like this, from U3 to all the other vertices. U3 to U1, how many edges we have? 2 edge. U3 to U2, we have 1 edge. U3 to U4, we have 2 edges. U3 to U5, we have 3 edges. U3 to U6, we have 3 edges. So from the vertex u3 to all the different vertices, we got the number of edges, the distance as 2, 1, 2, 3, 3. So the maximum value is 3. The maximum number is 3. This maximum value is called as eccentricity of the particular vertex. Likewise, let us find for u4. From the vertex u4, calculate, measure the number of edges between every other pair of vertices. u4 to u1, we have 2 edges. u4 to u2, we have 1 edge. u4 to u3, we have 2 edges. u4 to u5, we have 1. u4 to u6, we have 1. So what is the maximum value? It is 2. So E of u4 is 2. Likewise, we are going to find E of u5. Maximum u5 to u1, 3h. u5 to u2, 2h. u5 to u3, 3h. u5 to u4, 1. u5 to u6, 2. So the maximum value will be 3. Likewise, u6 to all the other vertices, we find the maximum value will be 3. So we find the distance between from the particular vertex to all the other different vertices. We choose the maximum value, and that maximum value is called as eccentricity. So after finding eccentricity, from the eccentricity value, choose the minimum eccentricity. The definition of radius is minimum of all the eccentricity is called as radius. So we find different eccentricity value with respect to a particular vertex. What is the minimum value of this eccentricities? Just the value. The minimum number is 2. Therefore, the radius is given by 2. Therefore, the radius is given by 2. Radius is nothing but minimum of all the eccentricities. The minimum of all the values of eccentricities. So the minimum value is 2. The smallest value is 2. So the radius is given by that particular minimum value. So this is how we have to find the eccentricity and radius. Now once eccentricity and radius are known, we are going to find something called central point. Central vertex. Which are the vertex where our eccentricity value and radius are found to be the same? Those points are called as central points. Those vertices are called as central vertices. So we got the radius is 2. Which are the eccentricities? Which are the vertices got the radius 2? Which are the vertices got the radius 2? Vertex u2 got the radius 2. Vertex u4 got radius 2. Therefore, the central point is nothing but u2 and u3. These are the two vertices where my radius value and eccentricity value going to be the same. So what is the definition of central point? It is given by E of V is equal to R of T. Which are the vertices? The radius value. Which are the vertices has got the radius value? So in our example, the vertices u2 and u3 have got the radius value. So this is called central point. And we represent this central point in the form of set. It is called center of a tree. Set of all central point is called as center of a tree. After finding the central point, when we represent in the form of a set, put it in the form of a set, represent in the form of a set. So this vertex u2 and u3 we represent in the form of a set. The set of all central point is called center of a tree. So this is how we define center of a tree. So hence, what is the definition of a center of a tree? To define the center of a tree, basically we should know what is eccentricity and what is radius. So we find eccentricity, we find radius. Then we should get the central point and represent the central point in the form of a set. So set of all central point is called as center of a tree. So this completes the concept of center of a tree.